Welcome to Logarithms, lecture number 2. In the last class, you have seen the definition of logarithm, which states if a power n equal to x, then log of x to the base a is equal to the exponent, which is n, where x is a positive number greater than 0, x is not equal to 1, a is greater than 0, where x and a are the real numbers. Now, generally, we follow common logarithms, natural logarithms, and logarithms in computer language. In common logarithms, the base of the logarithm is 10, this is log x to the base 10. In natural logarithms, the base of the logarithm is exponent, that is e equals to 2.18 and so on, which is an irrational number, and this log x to base e is nothing but equals to ln of x. And in computer language, we use base as 2 for the logarithms, log x to base 2. The logarithms has wide applications in the field of science and technology, maths and physics, not only maths and physics, in chemistry also. And it makes the very tedious calculations very easy, such as, suppose if you consider a number 3012 raise it to 531. So how do you calculate 3012 into 3012 into and so on 531 times? You have to take 3012 and you have to multiply. Is it possible? No. It takes so many papers, very tedious work. You don't know whether you may get finally your correct answer or not. But using the logarithms, within 2 minutes you can get the answers easily. And how we will study after doing some problems, by studying some formulae, etc. Now let's see one more application of logarithm in chemistry. In chemistry, in acids and bases, we see that the hydrogen ion, that is pH value, hydrogen ion concentration, that is pH, the pH value is defined as the negative logarithm of hydrogen ion concentration to the base 10. You know, it ranges from 0 to 14, where it reflects acidic, neutral, and basic character. Now let us see logarithmic identities. So the first identity is the product rule, which is written as log of AB to base 10 equals to log A to base 10 plus log B to base 10. So product of two real numbers, the log is applied, equals to sum of the individual logarithms to the same base, that is 10. So log AB to base 10 equal to log A to base 10 plus log B to base 10. The next rule is the quotient rule. Log of A upon B to base 10 equals to log A to base 10 minus log b to base 10. Log of a by b is equal to log a minus log b, where the base is same, that is 10. This is the quotient rule. Now we see power rule. This consider log of a power m to base 10, and this is equals to, this power comes here, m log a to base 10. That is the rule. That is log of a power m to base 10 is nothing but m log a to base 10. The next, see, base change rule. Next is base change rule. The next rule is base change rule. Here we consider log b to base a. Log b to base a. So the base change rule, we are changing the base. This can be written as log b by log a. Log b by log a, where we take the base as an arbitrary, it is suppose say this is c. Okay. Also, have log of b to base a is nothing but 1 upon log of a to base b. So very simple, this formula, where we are choosing the log b to base a. In this case, instead of choosing the c arbitrarily, we choose the c equals to b. And what happens here, log b to base c is nothing but b by log a to base b. Where log b to base b is nothing but 1. This is one of the rule we have. Log x to base x is 1. Sixth one. Log of 1 to any base a is 0. Seventh one. Log of 0 to any base a is undefined. So we can take it as infinity. Minus or plus infinity, depending upon here. We are taking the base. The log of negative number is undefined. So these are the basic formulae we have to work in our mind to solve the problems. Let's look at this question. Expand log of 343 by 125. So the question is only to expand, not to evaluate. So let us take its solution. It is log of 343 upon 125. So let us split them as log of 343 minus log of 125. Now what is the base? Base is not given here. If nothing is there, it is taken as base 10. Is that base 10? So you can take base 10. Whether you write base 10 here, doesn't write, it never matter, doesn't matter here. So log of 343 to base 10 minus log of 125 pi to base 10. How we got this? Log of a by b. It's the formula we have. Quotient rule. Log of a upon b to base 10, or anything you can say, is log a minus log b to the same base. It may be 10, or if you have to take another base, we get other base. So now for this, to factorize 343, is a 7 cube. 7 4 28, 6 9 63, 7 7 cube. So it's nothing but equal to 7 cube. Similarly, 125 can be written as 5 cube. Therefore, we write this as log of 7 cube to base 10 minus log of 5 cube to base 10. This equals to, again, log of a power n power rule. 3 log 7 to base 10 minus, this is again your 3 log 5 to base 10. So we have applied the power rule, that is log of a power m base 10 equals to m log a to base 10. So in this we take out 3 as a common factor. So what you get is log 7 to base 10 minus log 5 to base 10. So this are taken here once again. On factorizing 343, get 343 is nothing but 7 cube and 125 is 5 cube. So we write this log 343 as log of 7 cube and log 125 as 5 cube. So they say, okay. Again, I'm applying the power rule. Log of a power m base 10 equal to m log a to base 10. That we have applied for this. So what do you get here? 7 cube is 3 log 7 to base 10 minus 3 log 5 to base 10. This is an expanded form. You can leave here itself, or if you want, you can take 3 as a common factor. So what you get is log of 7 to base 10 minus log of 5 to base 10. If you want again log of 7 by 5 to base 10, 3 times off. Okay, this is an expanded form, or you can take 3 log 7 by 5 to base 10. So if you want to write it as only one number, here itself you can do it. That is 7 cube by 5 cube, that is 7 upon 3. 7 cube by 5 cube, so 7 upon 5 whole cube. So we get 3 log 7 by 5. But you are asked to expand. Therefore, expansion is this one. This one. So this is your answer.